Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, today I would like to present about power amplifier on electronic device and circuit. Okay, next. Okay, for the introduction, okay, a power amplifier is an electronic amplifier designed to increase the magnitude of power according to the input signal. The power of the input signal is increased to the level high enough to drive loads, such as device like speaker, headphone, or RF transmitter. Okay, it's also designed to drive a load directly, and it's used as a final block in an amplifier chain. Next. Okay, there are few type of power amplifier. It was divide into a few types of classes, and it was designed to amplify an analog signal. There were class A, B, and C. So we will go through one by one. Okay, for class A, the most common type of amplifier topology, as they use just one output, switching transistor bipolar, FET, and IGBT. The single output transistor is biased around the Q point within the middle of its load line. It's cut off or saturation region, thus allowing it to conduct a current over the full 360 degrees of the input cycle. Next. This is the circuit and graph for class A characteristic. Okay, next. Okay, this is the characteristic of class A, where is analog waveforms are made up of a positive, high, and negative low. All entire input waveform is used in an amplification process. Use one output switching transistor. This single output transistor is biased around the Q point in the middle of its load line. Next, class amplifier. Class amplifier operates in a linear region. Next. Class B. Class B is invented as a solution to the efficiency and heating problem associated with the previous class A amplifier. Uses two complementary transistor, either bipolar or FET, for each half of the waveform. The efficiency is much higher than that of the class A. Okay, this is class B characteristic graph and circuit. Okay, next. The class B characteristic is the transistor conduct only half of the time, either on positive or negative half cycle. Class B amplifier also conduct only through one half of 180 degree of the output waveform. The circuit behavior is time alternation, meaning flip-flop. It can create distortion at zero crossing point of the waveform due to the transistor dead band. Next. Okay, this is for class AB, a combination of class A and B type of amplifier. Common use in type of audio power amplifier. The class AB amplifier is a variation of class B amplifier. Next. This was the circuit and the graph characteristic of class B. Okay, next. Class AB. Class AB characteristic, eliminating the crossover distortion problem of the previous class B amplifier. The conducting device, either bipolar or FET, actually, provided by the series diode, eliminate the distortion as shown in the image of the circuit. More efficient and linear than the class A and B. Next. Okay, next is class C. Class C has the greatest efficiency but the poorest linearity of classes of amplifier. This type of Class C amplifier is heavily biased. The conduction angle for the transistor is significantly less than 180 degrees. This form of transistor biasing gave as much improved efficiency of around 80%, but it's not suitable for as audio amplifier. This was the circuit and the graph characteristic. Next. Okay, the Class C characteristic is not eligible for audio amplifier due to its heavy audio distortion, commonly used in high frequency sine wave, oscillator, and certain type of radio frequency. The amplifier output can be converted to complete sine wave of particular frequency by the use of LC resonance circuit. Next. Okay, that was all of the characteristic Class A, B, and C. Okay, this was the summary. So the Q point of an amplifier determines the amplifier classification. So different type of class switching technique is to reduce power loss and increase efficiency. Okay, the amplifier class description as shown below. Class A, full cycle of 360 degree of conduction. For the Class B is half from the Class A, 180 of conduction. Class AB slightly more than 180 of conduction, and Class C is slightly less than 180 of conduction. Okay, next for the calculation, for the question of calculation. Okay, we need to determine IB. Okay, basically IB is equal to VCC minus by VBE over RB. So we get IB 3.68 milliampere. Next. And after that we need to determine IC. IC is equal to beta IB, so IC is equal to 0.294 ampere. Okay, next. And for the VCE is equal to VCC minus ICRC. So VCE we determine, then we get 9.18 volt. Next, for IC saturation, VCC is over RC, so 18 volt over 30 ohm and equals to 0.6 ampere. Next. Okay, this is the graph for the IC saturation, where we can see the Q point of Class A. Okay, that's all from me. Thank you. And thank you.